All right, so we are talking 7.3, day 2. We are now graphing logs today, guys. We're going to graph these logs. All right, so first thing, let's go ahead and let's look at just example 1. All right, keep it simple. We're going to get our basic logs here before we get into anything a little more complicated. All right, so we're just going to focus on the simplest graph, which is y, or f of x, is equal to log base 2 of x. All right, so let's just focus on that, graphing log base 2 of x. All right, now when in doubt, if you have no idea what a graph looks like, plot some points. All right, so I'm going to call on people to help me plot some points. All right, so let me go ahead and call on. All right, Riley, start us off. Okay, so Riley, let's just start plugging in stuff. What do you want to plug in for x?
4.
4. Ooh, great number. All right, why did you pick 4?
Because if you square it, it's like an even number and a normal number, so it'd be quick in my head.
Yeah, so if you plug in 4 for x, what do you get for y?
2.
2. Perfect. All right, so we got 4, 2. Beautiful. Okay, let's do another point. Jackson, can you plug in a point?
Right, wait, what do I do?
Plug in a point. Pick a point to plug in to our function so we can plot this graph.
Is like any point or?
Yeah.
6 and 3.
Well, no, it has to fit into like you can't just like not just any point. Okay, I'm sorry, not any point. Pick a nice x to plug in. So we have log base 2 and then of x. So what's a nice x to plug in?
2.
2. Good. All right, so 2 is nice because what would y be?
2 or 4.
Okay, so remember log means 2 to what exponent gets me 2? So to what exponent?
1.
There you go. All right, so that's equal to 1. All right, so 2, 1 gets me there. Okay, nice. Mateo, let's do another one. Pick another nice point.
0.
0, okay. So then if I put 0, all right, so log base 2 of 0 will be equal to what?
1.
Is equal to what?
1.
Well, does 2 to the first power equal to 0? Not quite, right? Because we're asking 2 to what power gets you 0? So 2 to what power gets us 0, Mateo?
I'm not sure.
You know what? I'm not sure either because I actually don't think that's possible. Right? Like 2 to what power gets you 0? I actually don't think that is even possible. So I'm going to say not possible. Okay. And in fact, that's actually really important. There is an asymptote that Mateo just found at 0. So there is a vertical asymptote here because x can't be anything less than 0, right? It can't happen. 2 to what power would get you like -2? Doesn't quite work. Yeah. So good catch though. Yeah. So that isn't going to be possible. So let's try another nice number. I think a nice number would actually be 1/2. So Mateo, if I were to do 1/2, log base 2 of 1/2 is equal to what?
-1.
Good, -1. Excellent. At 1/2, I'm at -1. Okay, so you guys can kind of hopefully start seeing the graph here, and it's gonna look like that, approaching the asymptote and going this way. All right, so that is your log graph. All right. It's almost like the exponential graph, but kind of like flipped around. All right. It's like instead of a horizontal asymptote, it's a vertical asymptote. All right. And the equation of the vertical asymptote is x is equal to 0. X is equal to 0. Okay. Great job. Any questions so far? If you wanted to find domain and range, it's not asking you, but if you wanted to, the domain, does anybody know? Go ahead and put it in the chat if you think you know domain and range. Let's start with domain. If you think you know the domain, go ahead and put it in the chat. Good. Yep. Good. Not all real numbers actually for this one. Yeah, not for the domain. Good. Okay, so those of you guys who said x is greater than 0, you are correct. Yeah. So if you look at the graph, there's only graph to the right of 0, right? Not including it, but ooh, yeah, and the range. I think some people got the range already too. So yeah, try the range. What do you guys think the range is? Remember, scan along the y-axis. Where is their graph? Where is their graph? Good. Yes, 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 yes. Good job. The range would be all real numbers. Good. Nice, guys. All right. So if it were to ask you domain and range, that would be the domain and range. Okay. So let me go ahead and show you guys something real quick. Okay, so yeah, that's why there's no equal to sign. It never reaches that asymptote. Good. All right, so I just want to show you guys, this is the graph that we just made on our notes. But now I want to show you what happens when we change. All right, so we're at the top of your notes now, that box. Okay, what happens when we change these parts of the graph, like A or H or K? Okay. So imagine instead of A being 1, let's say it increases to 2 or 3 or 4 or 5 or etc. All right. So you can see that it's getting steeper as A increases. Let's see what happens when A gets lower than 1. So if A is like a half, right? So this is the original. If it goes half, it gets flatter, all right? And flatter and flatter and flatter and flatter. But what happens if it goes negative? Well, let's see. Oh, it flips over. So it was here, now it's here. It was here, now it's here. All right, so if A is negative, it flips over the x-axis. All right, so that's what A does. It kind of stretches it and flattens it. H inside the log, this is going to shift it horizontally. Notice this also moves the vertical asymptote. We can't see the vertical asymptote, right? But we know that's kind of where the graph is approaching. So we see that this is what will affect where the vertical asymptote is, this H. All right. All right, and then lastly, the K will shift it up and down. All right, so the K on the outside of the log will shift it up and down. All right, so I just want to show you guys a visual of what's in that box on your notes. All right, any questions on that? Everyone's good. Okay, let me switch back to my iPad. All right, and let's go ahead and start graphing some more of these. Okay, so a couple of notes I do want to make up here. When you guys have your graph of log, any log, just be careful of a couple things here. All right, so a couple rules. Number one is you have to make sure that b is greater than 0. Okay. B also, let me just number this. So number 1, b has to be greater than 0. B also can't equal to 1. And I'll let you guys think about why that is. And this is, I would say, most important. X can't be less than or equal to 0. So X has to be greater than or equal to 0, which we saw in our first example, right? So make note of these. And the B, the problem will always kind of set you up. So you don't really have to worry about B. It's the X is greater than 0. All right, what goes inside the log? That's what you have to be careful of. All right, so let's go ahead and graph number 2. And whenever you guys graph this, my advice to you is set yourself up with nice numbers to plug in for X. Kind of like what Riley did, right? For example 1, he plugged in 4 because he knew that it was going to come out nicely. So look at your base and of 3 here and think about nice numbers to plug in for X. Okay? All right, so let me call on people and see what you guys come up with. All right, Rachel, start us off. What's a nice number we could plug in for X if the base is 3?
3.
Yes, good. Plug in 3. That is a great number to plug in. All right, so when I plug in 3, I get -2 log base 3 of 3. Now, what's log base 3 of 3?
Is it 9?
Say it one more time.
9?
It's not 9. So remember, whenever you have a log, it's asking what exponent, right? So 3 to what exponent gets me 3?
1.
1, exactly. So then this, right, is just -2 times 1. Sorry, let me move all this so I can have more room. All right, so we plug in 3. So -2 log base 3 of 3 is just -2 times 1, which is equal to what?
-2.
Perfect. Nice. All right. So see what Rachel did there? She picked a great number, and that, leads her to an easy point to plot. Great job. Okay. Let's go to Paolo. What's another nice number we can put in to X?
1.
1. Great. Yeah. Let's plug in 1, because what's log base 3 of 1?
Would just be 3.
It's not 3. So think of 3 to what exponent gets me 1? 3 to what power will make it equal to 1?
Just 1 then?
Well, 3 to the first power gets me 3. I want to figure out 3 to what exponent would get me 1. What number should I put in that box? 3 to what exponent gets me 1?
I don't know.
Well, it's less than 1.
Is it just 0 then?
0. Yeah. 3 to the 0 power gets me 1. Good. So when I get -2 times 0, what does that equal to?
0.
Just 0. There you go. All right. So I have 1 and then 0, and that is my exponent. Okay. All right. Let's plug in one more number, and I'm going to pick it this time. I'm going to plug in 1/3. All right, 1/3. And let me go ahead and ask Celine, what do I get when I plug in 1/3? This would be -2 times, what's log base 3 of 1/3?
-1.
Good. And then -2 times the -1 will get you?
+2.
2. Nicely done. All right, so that gets me here. So we can already see that the vertical asymptote is still at 0. Great job, Celine. All right, so it's still at 0. So that's my vertical asymptote. X is equal to 0. And my graph goes like this. All right, and there's your graph. All right, so here is my helpful hint for you guys with the asymptote. Because it's a vertical asymptote, it will only change if you shift it left or right. Okay, so the variable that shifts it left or right is the h. Okay, h is what shifts it left or right. So your vertical asymptote is always going to be x is equal to h. Okay, so if you like having that vertical asymptote done first and then plotting points to it, you can automatically do that. All right, other things I want you guys to notice. Notice how the base connects with what you plug in for your x, right? So the easy numbers when it was base 3 was 3, 1, and 1/3. The easy numbers to plug in when it was base 2 was 2. You could actually plug in 1. Actually, let me change that. You can plug in 1. All right, and let me change this now too. Sorry, I thought I plugged in 1. You get 1, 0. All right, and then you plug in that and you would get nice numbers. So the base relates to what numbers you plug in, okay? All right, let's jump to number 4 actually. Let's jump to number 4. So I want to graph log base 3 of x plus, do I want to do number 4? Sorry, changed my mind. Let's go to number 3. All right, number 3. First, let's do the vertical asymptote. Okay, so in the chat box, I want you guys to tell me, what do you think the vertical asymptote will be for this problem? Where is the vertical asymptote? And make sure you have x is equal to start with. X is equal to. Okay, okay. What do you think the vertical asymptote is? Good, yeah, Give me the equation of the vertical asymptote. Good, good. All right, I'm getting 2 possible answers right now. Okay, all right. So my 2 possible different answers I'm noticing are coming up are x is equal to 2 and x is equal to -2. Okay, so let's figure out which one it is. So looking back at the formula up here, this is x minus h. So in the problem, it was x minus 2, which means h should be equal to +2. All right, so be careful with that minus there. All right, so final answer for this one should be x is equal to 2. Okay, so be careful with that minus. So that's my vertical asymptote at x is equal to 2. Any questions about that? Okay, good job, people. All right, let's go ahead and start plugging in some nice numbers. Okay, so x, let me scooch this over, give myself a little more room, and y. Okay, help me plug in some stuff. Betty. Oh, Betty's not here today. Let's go to Liam. All right, Liam, let's pick a nice number. What can I plug in? Look at the base. I got 1/4. What's a nice number to plug in?
I don't know. 1/4.
1/4. Yeah.
Okay.
Yes. Now, here's the thing. I want the whole thing inside to be equal to 1/4, right? Because that will give me a y of just 1, right? Because that log of 1/4, 1/4 to the 1 power will get me 1/4. So now what does x have to equal then? If x minus 2 is equal to 1/4, what does x have to be?
2 and 1/4.
Yeah, exactly. Yep, perfect. Because from here to here, I need to add 2. So just add 2 and you get 2 and 1/4. Perfect. All right, so I'm going to plot that 2 and 1/4, and that gets me 1. All right, great. All right, let's go ahead and do another one. Let's go to Angie. Angie, what's another nice number to plug in for x minus 2?
1/16.
Oh, yeah, sure. 1/16. Okay, so then what does x have to be then?
2 and 1/16.
Good. All right, and then when I plug in that 1/16, what do I get for y?
2.
2. Good. All right. So 2 and 1/16, I get 2. So even closer to that asymptote. Okay. All right. Give me one more number to plug in. Michael Y.
I was gonna say 3, but like that doesn't really go with the numbers we have.
Oh, yeah. So, okay. If you look back at my pattern here, let's look at number 2. What I always plug in is the base itself, the number 1, and then the reciprocal of the base. I think those are the easiest numbers to plug in. So far we've got the base itself. Okay, we got an extra 1 here. All right, 1/16. So what's another number I can plug in? Where we got the base itself, I have 2 other options now.
So 4.
Yeah, do this reciprocal. So let's do 4. All right, so plug in 4. What does x have to be for x minus 2 to equal to 4?
6.
6, good. And then if I have log base 1/4 of 4, what does that give me y?
-1.
Perfect. All right, so 1, 2, 3, 4, -1. Good. All right, and then the middle one, though the 1/16 is okay, I probably could have skipped this one and I would have gone for just 1. Okay, so notice again, just the same base, 1, and then the reciprocal. I think those are the only 3 points you guys really need. Okay, so if x minus 2 is 1, I add 2 to get just x, so that gets me 3. And log base 1/4 of 1 is 0, right? Because 1/4 to the 0 power is what gets me 1. All right, so I'll plot 3, 0, and that gets me this one right here. And that is your graph. Okay. All right, so again, when you plot your points, just use those 3 points. The base itself, the number 1, and then just the reciprocal of the base. And that will get you the curve. Okay? All right, let's try one more. So number four. Let me set this up, and oh, that looks like a pretty blue. I'll use this one. I think this was the same paint color as my room in the early 2000s. All right, so let's set that up. Oh, let me actually do x plus 1, right? That's what's inside the log, and that will help me figure out what x and y need to be. Okay, let's start with actually the vertical asymptote. So in the chat, go ahead and test yourself. See if you can tell me what the vertical asymptote for number 4 should be. Try it out. Vertical asymptote for number 4. Oh, give me the whole equation. Give me x is equal to. Okay, good. Better. Good. Still waiting for more. What is the vertical asymptote? Oh, I have a question. Why is that asymptote vertical instead of horizontal? Yeah, good question. Well, when we plotted the points, we kind of saw that there was a limit to what x could be. Not what y can be, but there was a limit to what x can be just based off of the definition of log, right? So for the definition of log, we know that x has to be greater than 0. So that's why it's a vertical asymptote, because there's a limit of what x can be. Does that answer your question? Cool. All right. Still waiting for a few more vertical asymptotes. Good. Nice. Okay, I think most people got it. Careful, some people did still put x as 1. All right. If this is x minus 1, or h, excuse me, that means h must be negative 1. All right, so be careful, make sure you flip the sign. So x is equal to negative 1 is the vertical asymptote. All right, so let's draw in that vertical asymptote. And let's plug in some points. Here we go. What should we plug into the log? Let me go to Sebastian. All right, Sebastian, what's a number I should plug in for log?
For y.
For the into the log. Notice it's base 3. So what should I plug into the log for x plus 1? Notice our example here.
3.
Oh, go for it? Yeah, 3. Good.
3. Just start with 3.
Yeah. And actually give me the other numbers too. All right. We plug in 3. What's another number we should plug in?
9.
We can, but you don't need to. So look at the example here. We plugged in 1/4, 1, and 4. So it's the number, the 1, and its reciprocal. So 3.
1/3.
1 and 1/3. Yeah? Okay, so those are the numbers we want to plug in. Okay. Help me out with the next part. Gloria, to get from x plus 1 to x, what do I need to do?
Wait, I'm a little confused. Do you plug in the 3 or?
No, I'm not plugging in 3. I'm thinking, what does x have to be? So
oh, okay.
1 is 3, then x must be. Or here, sorry. That's a confusing way to say it. Sorry. To get from x plus 1 just to x, what do I need to do?
Minus the 1.
Minus 1. Okay. So then if x plus 1 is 3, I'm going to minus 1, which gets me.
Wait, so x.
So
Wait, 2?
yeah, 2. You just minus 1. Okay.
Minus.
And then the 1 would be. So to go from here. Huh?
Wait, the 1. Oh, okay. So
Yeah.
continue.
Yeah, keep going.
And the 1 is going to be 2.
No, remember we're minusing 1. We're just subtracting 1. So 1 minus 1.
0.
Uh-huh. And then 1/3 minus 1.
Negative. Negative 1. And 2/3.
Good. Okay. All right. So those are your x's. Good. All right. Now let's go ahead and figure out what the y is. Okay. So I have log base 3 of 3. All right. And we already know, hopefully, we're running a little low on time, so I'm going to speed through this a little bit more. So if I plug in the 2, I get log base 3 of 3, which is 1, minus 3, which gets me negative 2. All right. And then when log base 3 of 1, I get 0 minus 3, which is negative 3. And then when I plug in 1/3, I get negative 1 minus 3, and I get negative 4. All right. So we're going to plot these guys right here. And I get 2, negative 2 right there. 0, negative 3 right there. And then negative 2/3 and negative 4 right there. All right, so that is my graph right there. All right. So hopefully you guys are starting to see this pattern and it kind of just like starts repeating itself after a while. All right. Cool. Let's get to this last part and I think we are good. So let me have a reader, please. Bowen, can you read this one out for us?
The general time of victory is the time of its take to the population to double. The generation time G for a specific time vector can be found using experimental data. And the formula, whereas T is the time period, B is the number of vector at the beginning of experiments, and F is the number of vector at the end of experiment. An experiment environment involving rats and had been exposed to Slimer, so the generation time of Slimer was 5 hours. After how long would 20 of those multiply into 8,000?
Thank you. Yeah, there's some tricky stuff in there. Salmonella, I think. All right. So let's go ahead and let's plug in the numbers in what we know. So they say that the generation time for
Miss Leong,
yeah.
I have a question. Can you get salmonella from salmon?
Ooh, I think you might be able to. It's like a bacteria. I feel like I hear of it more on like chicken, but I'm
Oh, so it's chickenella then.
ha 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 ha
Ah,
ha. That's a good question. I'm not sure, but I think I'm going to say yes. I'm going to go with yes. It can be.
all right.
You can fact check me on that. All right. Let's see. So we have G is the generation time is 5. How long would 20 of these bacteria? So that's the starting. All right. So this is B. Multiply into 8,000. So that's our end of the experiment number of bacteria. All right, so let's plug in our stuff and solve for T. So we got 5, T's on top, 3.3, log base B is 20, F is 8,000. All right, so let's solve for T. As always, start with log. Log base 20 of 8,000. What is Oh, somebody's unmuted. If you could mute yourself. Thank you. All right. So log base 20 of 8,000. Let's see who can be the first one to get that. What is log base 20 of 8,000? Go in the chat. Ooh, Good job. Nice, Leo. All right, that was quick. All right, so the answer was 3. Nice, because 20 to the third power is what gets you 8,000. All right, so then that's going to be t over 9.9. Multiplying that over, so t is equal to 5 times 9.9, which gets me 49.5, if I'm not mistaken. Somebody double check that for me. Yes, I think that is correct. All right, so that is 49.5, and t is in hours. All right. And there you go. So pretty confusing looking formula with a lot of material, but once you grab all the stuff, all the variables you need from the problem, plug it in, simplify it, you're good. All right, good job, guys.